I said that the number e that we defined in this very strange way, saying, well, we want an exponential function whose derivative at 0 is 1. And I said that this definition was somehow natural. Now comes another natural thing, namely the natural logarithm. And it's defined as the inverse function of the logarithm, or of the exponential function with base e. So it's the logarithm with base e. So we write this as ln of x. The ln is written ln because I think it was a French manuscript that introduced this notation, so Logarithm naturel or something like that. Just think of it as natural logarithm in reverse order. And a nice thing about this is that the derivative of this function is just 1 over x. So the derivative of ln x is just 1 over x. Of course, for any positive x, it has to be defined which logarithms are only at positive numbers. So if you go down, if you go a 1 unit length step along the x-axis, the tangent will have 1 over x as the slope up here. Right? So if I move this around, I've made a small trick here, because usually we always take unit steps here. But then, I mean, what is a unit length here? It's something like this, and then you go up here, and then you will have a very small line here along the y-axis, which will very soon be impossible to see. So instead, you can choose to see this as for this less than 1, we have the normal way of illustrating it. For x larger than 1, instead of keeping the x step fixed and the y step equals to 1 over x, you can just multiply both by x, and then you have x and 1. Right? So in other words, for the logarithm, if you take a step of length x, you only go 1 up. And that applies anywhere, right? So if you're at 14 and go 14 ahead, then you just take 1 step up. So this is a very, very slowly increasing function. So far this has only been claimed. Now we want to prove it. And we can do this using the chain rule, because we know that x is equal to e of ln x, or e to the power ln x, right? If you compose an exponential function with its corresponding logarithm, you just get the identity. So what do we get if we differentiate x? We just get a 1, right? So this is what we write here. 1 is equal to the derivative of x. But since x is equal to this, it should also be equal to the derivative of this. And we know how to differentiate the exponential function. And then we can use the chain rule to pull out this in front and then multiply it by e to the power ln x, because this is the derivative of e with this inserted, right? So e to the power ln x is just x. So in the end, we can just write this as the derivative of the natural logarithm at x times x. And we have a 1 over here. So 1 is equal to this product. If 1 is equal to this product, we can just divide by x on both sides to isolate this. And then we get that d dx ln x is 1 over x, which is what I claimed.